Hi there, welcome back to the channel. Today, I'm going to be talking about part 2 of the chapter Discriminant. So for those of you who have yet to watch part 1 of the Discriminant, do check out that video first before watching this. As in this video, I'll be making some reference to concepts that I've taught in that video. Also, I'll be putting the link on top or below so that you can have easy access to the video. For the rest of you who have already watched part 1 of the Discriminant, in this video, I'll be elaborating on the 3 scenarios and I'll be going through concepts that are required for this chapter or concepts that will help you better understand this chapter, so that by the end of the video, you will understand all the conceptual knowledge that is required for this chapter. Alright, without further ado, these are the various sections of the video, and you can use the timestamp given in the description box to navigate through the video. Also, for those of you who are rewatching this, you can just jump to the various sections that you're interested in. And if you found the video beneficial, please do all the things that you typically hear most YouTube channels ask you to do. Thank you. Alright, let me begin from where we left off in part 1 of the Discriminant. The 3 scenarios. The first is where there are 2 distinct real roots. The second is where roots are equal, also known as one distinct real root. And the third is where roots are not real. And you will notice for each of the scenario, there is this b squared minus 4ac thing at the bottom. Let me just say that this b squared minus 4ac thing has a name. For those of you who have already learned this chapter in school, you may already know that it's called the discriminant. For those of you who are hearing this the first time, yes, this thing is called the discriminant. A rather fanciful name for a formula if you ask me, but still, it's just a name, and let's just take the name as it is first. Now, what if I tell you that this discriminant formula is not totally foreign to you? What I'm trying to say is that you've seen this formula before. If you're not convinced, let me just bring out a formula for you. For those of you who are at upper sec, this formula should be familiar, as you will have already learnt it in the lower secondary. This is your formula to solve quadratic equations, and in part 1 of the discriminant, we did briefly see this formula as well. Now, what is this formula doing here? If you haven't already noticed, this part of the formula looks identical to the discriminant. In fact, this formula is where the discriminant originated from. Which makes a lot of sense actually, if you think about it. Because when your discriminant is greater than 0, meaning your discriminant is positive, what will this formula give you? When you solve for x, you obtain 2x values, 2 solutions. So when your discriminant is greater than 0, you get, as the name implies, 2 distinct real roots. Since in a layman way, roots are basically solutions. This thing here just means that the 2 roots you get are different from one another, as you can see. And real refers to the answer being a real number. Now, we can follow this train of thought and see that when the discriminant is 0, there is indeed only one solution. So, hence, one real root or roots are equal. And when the discriminant is lesser than 0, there are no solutions, since you can't square root a negative number. Hence, your roots are not real, meaning there are no real roots. At this stage, I would like to say that what I have explained about the three scenarios in terms of their description is shown very nicely by the graphs here. What do I mean? When you have two distinct real roots, meaning two solutions when you solve a quadratic equation, that can only happen when your curve and your x-axis intersects above this point, where this point here is your turning point, and more specifically, your minimum point in this case. Oh, and for those of you who didn't realize, these are the graphs to represent each of the three scenarios. So by right, since they are graphs, you should have your axis with this line here being your x-axis for now. Now let's talk a bit more about your turning point. This is a special point to talk about, as just by shifting the intersection of your curve with your x-axis to this point, you will get your second scenario, where your roots are equal as your curve and your x-axis intersects at only one point. Now, if you continue this thought process and imagine if the x-axis is somehow pushed further down beyond the turning point, what we will realize here is that we'll get the third scenario, where your roots are not real, as there is no intersection between the curve and the x-axis. At this point, I know what you might say, that this analogy of moving the x-axis down to portray the second and the third scenario is not very logical. And I agree with you, because we know that the x-axis is fixed. It is and always will be your y equals to 0 line, a horizontal line, and nothing will change that. Which means if the straight line is fixed to be your x-axis, your y equals to 0 line, to logically portray the three different scenarios, the quadratic curve to depict each scenario must be different. And that is quite a logical thought, since there are only two things here, your curve and the line. If the line is fixed, the only way to get the three different scenarios is to have different curves, and that is true. You can take a look at these equations and you will know it's true. Alright, at this point, if you need, you can take a moment to process these equations. You can pause the video here and solve the three equations using your calculator, and you'll be able to see that they represent each of the respective scenarios. If that is okay, let's go on to what I was saying earlier on. Remember earlier on, I said that these lines are your x-axis for now. What that means is that these lines do not necessarily have to be your x-axis. What I am saying is that there can be any horizontal line, or any line for that fact. If you're confused at this stage, think about it. I just said that when we are examining the three scenarios, we are examining the intersection between the curve and the line. Since there are only two things here, I can fix the line and change the quadratic curve to illustrate the three different scenarios, just like what I've shown you earlier. Alternatively, I can fix the curve and change the line. So that means, now, this line can be anything. It doesn't have to be your x-axis, it doesn't have to be a horizontal line, it can be any of your typical y equals to mx plus c line. Let me show you. Now let's use back our curve y equals to x squared plus x minus 2. If you found this quadratic equation familiar, then good. You've been paying attention, because this is the same quadratic equation and curve that we drew in part 1 of the discriminant. Now, I'm going to show you a bunch of lines. We can all agree that this line and this line will meet the curve at 2 points, right? This line and this line will meet the curve at 1 point, and these two lines will not intersect the curve. Now, what I've shown you is basically this, except now I've just put in the equations for the lines. And let me prove it to you that the equations that I've put in make sense. For the left side, these are horizontal lines and it's easier to prove. So let's just bring up our graph from part 1 of the discriminant. And you'll be able to see that the equations of the horizontal lines do make sense. Now, what about this? These lines are your typical y equals to mx plus c lines, which means they have a gradient and a y-intercept, and it's not so easy to show how they will appear on a graph paper. But there is one neat trick for that. Let me just show it to you with one of the line. This line, your y equals to x plus 2. Now, because this is a straight line, all we need is just 2 points, and we will be able to plot this line onto the graph. And the 2 points that I'll conveniently choose are going to be this point and this point. Reason being, these points are the y and the x-intercept. And it's easier to find the coordinates of these points. All you have to do is to sub x equals to 0 into the equation and get the y coordinate. Sub in the value of y equals to 0 to get an x coordinate. And there you have it, your 2 points for this line. And connecting the 2 points will give you your y equals to x plus 2 line. You can rinse and repeat this for the other equations, and you will see that they are indeed the straight lines that you have obtained. And more importantly, they will intersect the curve at 2 points, 1 point, and none. And this nicely concludes my point that I can fix the line and change the quadratic curve to illustrate the 3 different scenarios, or alternatively, I can fix the curve and change the line. Now, if you understood all of this, good job. At this stage, you have already understood all the concepts required to be proficient in this part of the discriminant. But you're still lacking in just one small part, and that is the method to solve questions from the discriminant. Now, in the next and final video of the discriminant, I'll be teaching you the various methods to solve discriminant questions, as well as linking the concepts that you have learned to the solving method, so that you can understand why those steps are the steps you have to perform when solving discriminant questions. Also, I'll be breaking down for you the different question types and the method to solve them. So do check out part 3 of the chapter when it's out, and thanks for clicking onto this video. I'll catch you in the next one, and have a great day ahead.